When working with the composition of functions, when you're trying to take the derivative of them, we have to use a chain rule. So for this function in part A, 3x plus 1 raised to the 100th power, this is a composition of two functions. Before I start doing the calculus, I like to do a little bit of color coding to get a good idea of what the outer function is and what the inner function is. So the outer function, if I was to step back really far away, I would see this as some stuff raised to the 100th power. And inside that bubble, we would have the 3x plus 1. So when taking the derivative of this composition, we can ignore the 3x plus 1 for just a second and focus solely on the outer function x to the 100th. I know exactly what the derivative of that is. It's 100 x to the 99th power. Once we identify the derivative of the outer function, then we work with the stuff on the inside. First of all, the argument that goes into this bubble is the same thing that we had in the original bubble, 3x plus 1. But then we're going to take the derivative of this 3x plus 1 and multiply it in the back end, so the derivative of 3x plus 1 is simply going to be 3. So multiplying the 100 in the front with the 3 in the back, we get 300 3x plus 1 to the 99th power. We can follow this routine for other functions. Let's say we wanted to take the derivative of the square root of 7x squared plus 5x minus 1. Again, before I take derivatives, I'm going to get a clear sense of what my outer function is. Radical x is my outer function. And what my inner function is, 7x squared plus 5x minus 1, is my inner function. So the derivative of this composition, I'm going to focus solely on the outer function first. The derivative of the square root of x is 1 over 2 radical x. So 1 over 2 radical x. But instead of an x, I'm going to have that same argument that I had there, 7x squared plus 5x minus 1. Then I'm going to take the chain rule derivative of this function, place it right here. So this guy times the derivative is going to be 14x plus 5, and make sure you put parentheses there. It would be incorrect if you didn't. And if you look at simplifying this, it will look a lot neater if we put the 14x plus 5 on the top and the 2 radical 7x squared plus 5x minus 1 on the bottom. Makes it look like a nice single fraction, right, as opposed to a bunch of things multiplied. Let's continue and differentiate the function cosine of, let's say, radical x squared plus 1. Now, for this problem, you can view it as the composition of 3 functions and not just 2. For my outer function, I'll have the cosine, clearly. And as I work my way inwards, I see a radical. And if I work my way further inwards, I see an x squared plus 1. So it's the derivative of a composition of 3 functions. And we're going to attack this in just the same way. Again, first I'm going to focus on the derivative of the outermost function. The derivative of cosine is negative sine. In for this argument is going to be the same thing I had for the original argument. So you'll still put in a radical x squared plus 1. And now we got to take the derivative of this function and multiply it in the back here. You could think of this as sort of starting a whole new problem and saying, hey, you have y equals x squared plus 1 inside the radical. What's the derivative of that? So this is just taking the derivative of a function composed of two functions. So again, I'm going to focus on the outer function, the radical. The derivative of the radical is 1 over 2 times the radical. Inside the radical, copy and paste the original argument. And then we're going to take the chain rule derivative of that x squared plus 1, and we'll have a 2x. Notice that that 2x is the derivative of my innermost function. And once we get to that point, that's how we know we're done. I see that this 2 and that 2 cancel out. So yeah, things don't really simplify all that much here. You have negative sign of radical x squared plus 1. In the back, you have x over radical x squared plus 1. Yeah, nothing more to do here because some people might want to do this, but this radical is inside the sign, so we can't cancel them out that way. And finally, for part D, let's say we're trying to take the derivative of e to the 5x cubed plus 13. Again, view this as a composition of functions. My outer function is the exponential. My inner function is that polynomial. Consider that you do know the derivative of the exponential. The derivative of e to the x is e to the x, right? So if we're computing the derivative, we'll compute the derivative of the outer function first. Ignore that red stuff for just a second. The derivative of e to the x, again, we said was e to the x. So f prime is equal to e to the argument. Inside this argument would go the original argument of 5x cubed plus 13. And then we're going to take the chain rule derivative of 5x cubed plus 13 and multiply it in the back here. So that's 15x squared.